All right, welcome to the deep dive. Today we're looking at a fascinating piece of hardware, the Thor broadcast F-8Tel transceiver. It's basically a bridge between two completely different eras of technology. Our mission today is to figure out how this little box takes classic analog telephone lines, what we all call POTS, and moves them onto a modern fiber optic network. Which, brings up the obvious question, why even do that? Why put old phone lines on super high-tech fiber?
Well, it really boils down to one word: security. The F-8Tel can carry up to 8 of these analog lines over fiber, and here's the kicker. The source material says the connection is, I'm quoting, impossible to bug.
Impossible to bug.
Yeah,
Well,
exactly. You're taking an old communication method that's notoriously easy to tap, and you're making it incredibly secure just by putting it on light. It's a total game changer for high security needs.
so you're basically armor plating the analog signal. Okay, if security is the main goal, how does it actually work? I mean, are we talking about some complex proprietary setup?
Not at all, and that's the beauty of it. It uses the standard two-wire POTS ports everyone knows. The real magic is inside. It's a transceiver, so it converts the signal both ways, and you just tell it what job to do with a simple little DIP switch. You pick either FXO or FXS mode.
Okay, let's break that down. FXO and FXS, what's the difference?
So FXO mode, think of that as the office side. It's the trunk connection. It connects back to the main PBX or the central switchboard.
Got it, the source. And FXS.
FXS is the other end, the user end. That's where you plug in your actual telephone set or a fax machine or, even a classic dial-up modem.
A dial-up modem, so it really is designed for legacy gear.
Absolutely. That flexibility means it can handle pretty much any analog equipment you throw at it.
And I saw it supports other features too, like caller ID pass-through, which is important, and something called an FXS to FXS hotline function.
Right, that just lets you connect two phones directly to each other through the fiber. No switchboard needed. It's all about creating a simple, reliable connection.
Reliability is one thing, but the feature that really jumped out at me from the specs was the sheer distance this thing can cover.
Oh, yeah.
We're not just talking about wiring up different floors in a building here.
Not even close. If you're using single-mode fiber, which is what carriers use for long-haul stuff, the F-8Tel can transmit that signal up to 20, 40, or get this, even 80 kilometers, depending on the model.
80 kilometers? That's incredible.
It is. Even on the shorter range multi-mode fiber, you're still getting around 3,000 feet.
Okay, but if you're connecting something 80 kilometers away, maintenance has to be a nightmare. You can't just send a tech out to check on a blinking light.
You absolutely can't. And
Yeah.
that is precisely why they built in support for SNMP.
Simple network management protocol.
Exactly. For any big enterprise or service provider, SNMP is it's non-negotiable. It lets them check everything remotely, the status, the fiber link, any alarms.
So you have full visibility from a central office.
Full visibility is what gives you the reliability you need to actually use a link that long.
So when you pull it all together, what we're seeing here is a way to take this decades-old, super reliable analog infrastructure and not only make it secure, but basically future-proof it with modern optical tech.
It's the perfect convergence, really. Dependability and security.
So what's the final takeaway here?
Well, here's a final thought to leave you with. You take that 80-kilometer maximum range,
Ah.
and you combine it with the device's MTBF, the mean time between failures.
Which is how long it's expected to run without failing.
Right. And for this device, it's 125,000 hours. That is over 14 years of continuous operation.
14 years.
So now think about what kind of critical long-distance systems would need that kind of reliability and that level of unbuggable security. Maybe remote utility grids, oil pipeline monitors, or vast border surveillance systems. Things that absolutely must not fail and cannot be intercepted. This kind of tech is probably out there right now, quietly keeping some very important infrastructure online. That's something to think about.